let's see now what we've missed. Okay, I think we missed the quotations here. Let me run this code now. I'm gonna explain it in detail what each of these means. Okay, so the log regression grid to find the to create hyperparameter grid for the logistic regression. So we call it as log regression grid. C, as I mentioned, it's the regularization parameter for the logistic regression. It controls the strength of the regularization. Smaller values of C indicate stronger regularization, which means a simpler model, while larger values of C reduces the regularization, potentially create more complex model. So the NP log space here, this generates 20 values for C, spaced evenly on the log scale from 10 to 410 in the power of -4. So this allows you to try broad range of regularization strength. Okay. On solver, we've chosen it to be lib linear. Solver is specifies the algorithm to use the optimization when we use the lib linear is used for small data set when C is not too large. It works well for binary classification problem, which in our case. Other solvers like Newton, CG, or Saga, or uh, LBFGS can be used for larger data sets, but here, like liblinear is chosen because it's enough and our data set isn't that large. This is for the grid for the logistic regression model. Let's move now for the random forest classifier. The N estimator here, it's the number of trees on a random forest that you are testing the values from 10 to 1,000. Here we choose 10, start by 10 and ends by 1,000. And the step how 10 is moving is by 50. So we can say that the N estimators is the number of trees in the random forest. Yeah, so the max depth also is the maximum depth of each decision tree in the random forest. None means nodes are expanded until all leaves are pure. So in our case, we are testing the values of 3, 5, and 10, and none to see if constraining the depth improves the performance of the model. The minimum sample split here you have is the minimum number of samples required to split an internal node. You are testing the values from 2 to 18 or to 20, and each step it goes by 2. So the larger values can prevent the tree from growing too deep or making the model too complex. So the minimum sample leaf here we have also, it's the minimum number of samples required to be on a leaf node. Larger values prevent the model from learning overly specific patterns. So this is exactly how we created a grid, hyperparameter grid for both logistic regression model and for the random forest classifier model. Next, we are gonna see how we can start, doing some random hyperparameter tuning for the logistic regression. Now, after that, we have set our hyperparameter grid for both of the logistic regression model and for the random forest classifier model. So the next step here is to tune them using randomized search CV. So what exactly meaning by tuning logistic regression using randomized search CV. This is a process of optimizing the hyperparameter of a logistic regression model to improve its performance. So we will go through each of these steps and then we'll write the code. So exactly what is randomized search CV? So as I said, it's a hyperparameter tuning technique where a fixed number of hyperparameter combinations are randomly sampled from a specific grid. Unlike grid search CV, which tries every possible combination, randomized search CV think as a sample given a number of combination based on the number of iterators, making it faster and more efficient, especially with large search space. I'll start typing the code and then I'll go through each of these steps so we can understand the code exactly. First here, let's put the first comment. Let's tune logistic model. We'll start by identifying a random seed by p dot num dot seed as usual equal to 42. This is to ensure the reproducibility of the code. So every time you run the code, you get the same results. Next, now let's set up random hyperparameters search for the logistic regression model. Model. To do that, we'll start by defining the rs logs. Okay. That has to equal to randomized search CV and then we'll set the logistic regression model. Okay. Then we'll set the prime distribution now. Distributions to equal to be log. Set grid. And now let's identify the configuration of that regression grid. Let's set the CV equal to 5 and the n equal to 20. Don't worry, I'm gonna explain each of these codes in detail. Set it to true. Okay, we're done here. So lastly, let's set the to fit the random hyperparameters. Search model for the logistic regression model. And to do that, we'll start by just calling again the rs log, take the regression, then we'll use the dot fit. We'll set the X train we have, our data, and Y train. Let me run this code because it will take some time to find the best parameters that our logistic regression model should use. So it will take like a minute or two. Within that time, I'll explain each of these